Okay, very good afternoon to one and all present here. I welcome everyone. Thank you for joining us for today's webinar. Prayer is the key of morning and the boat of evening. I would like to invite Mr. Paul Davidson, sir, to start the session with prayer.
Let us pray. Loving Heavenly Father, we thank you for your blessings and mercy showered upon us each day. We take this opportunity to thank our college for supporting and providing facilities to conduct this webinar in a fruitful manner. Lord, especially bless the organizers for their sincere effort in conducting this webinar. In this juncture, Lord, we thank our resource person, Dr.K. Joseph Abraham. Lord, be with him and guide him throughout this session. Let this session be a thought-provoking for each one of us who are part of this webinar. We hand over rest of the things into your mighty hands. We ask this in the name of our Lord and Savior, Jesus Christ. Amen.
So, now I would like to request Mrs. Iris Nita ma'am, Association in charge of BCA, to welcome the gathering and introduce our guest by few words.
It's my great honor to welcome and introduce the resource person of today's program, Dr. K. Joseph Abraham, Assistant Professor, Department of Information Technology, School of Computing, SASTRA Deemed University, Tanjavur. He has many years of experience in the field of teaching and research. He has published a number of papers in reputed journals, including Scopus Indexed Journals, Science Directed Journals, and much more. He is a member of International Association of Engineers and a member of I Explore International Research Journal Consortium. He has extensive experience in research as Senior Research Fellow and project funded by Defense Research and Development Organization, Hyderabad. He was working in the Department of Electronics and Media Technology in Karunya University, Coimbatore, and in the Department of Electronics and Communication Engineering in KL University, Andhra Pradesh. Currently, he is working as Assistant Professor in the Department of Information Technology, School of Computing in SASTRA University, Tanjavur. We are very glad to have you here, sir. I welcome you, sir. And also, I would like to welcome all the faculty friends and the research scholars of various colleges and our college for today's webinar. We expect your active participation throughout the program. Once again, I welcome you all for this webinar. Thank you.
Thank you, ma'am. Kindly take over section, sir. Please, sir.
Joseph, sir, you proceed.
Joseph, sir, you can start your presentation.
Yeah, thank you. Am I audible, sir?
Yeah, it's audible, sir.
Yes.
Yeah, thank you. Thank you very much. On the outset, before going into my presentation, I would like to thank the head of the department, Dr. James Manohar, the convener, and the co-conveners, my colleague, Ranjit Kumar, sir, and the management of Bishop Weber College for giving me this opportunity to share my insight on this webinar. Yeah, is my slide visible?
No, sir. No. Yes, sir.
Yeah, thank you. So moving into this topic, so we have fixed on with the image processing recent trends and applications. Image processing, it's going to be a highly mathematical, computational field in which will be discussing, but As of today's discussion, I'm not going into the depths of mathematics, but I'll be discussing about the various applications through which we can extend on the field of image processing. Okay, so there's a anonymous quote which says that one picture is worth more than 10,000 words. Obviously, it's a very true quote where we try to express our feelings or whatever it is. Even a small kid, we can explain it very better than in an image than expressing in words. This is a very true quote. But my question is, does all the images can express what we like to express? My question is that. So looking at this image, which is shown here, maybe giving you a clue that a girl standing in front of a scenery or a girl standing in front of a beautiful picture, you try to say the girl looks very beautiful, the girl looks very pretty, but this image does not gives any idea of the girl looking pretty or beautiful. So this image doesn't convey any information to us, isn't it? And similarly, I may give you one more example. This is the famous picture of an Eiffel Tower captured in a night mode. You see three versions of the same image captured in a night mode, but still you cannot visualize the image, you cannot understand or you cannot admire the beautiness of this image. So what I would like to bring out from here is purely any image or any image captured under any type of camera or any resolution will not be able to give us the feeling or convey the idea which we try to convey. So we need to process it. We need to give it more extended versions of that image in order to make it more clear. So the same image, after processing it, maybe you look at the image now. Okay, now you are able to admire the image. You are able to admire the way in which the Eiffel Tower looks now. Okay, so this is what actually the image processing tries to do here. Okay, so this is what I want to feel how image processing will be useful to us. On the left, you see a non-processed image, a very blurred type of image. Okay, we have various factors or various reasons why this image has been blurred or why this image has gone wrong. But keeping that apart as of now, but what I would say is when we want to express something through an image and without an idea of an image processing, it's very hard to do it. And nowadays people, especially the youth, the college students, all of you have mobile phones in your hand. You take selfies, you take group photos, you take various pictures, but you also apply some beautifying effects which are available in your cell phones. But what actually happens behind it? What actually makes you look very beautiful after you take a selfie? You introduce various emotions and you introduce various emojis into your same picture which you have captured. But how come these things become possible? And it's barely based on image processing and image processing techniques which are going to be used here in order to do all these effects or bring your emotions out using an image. So the outline of my presentation is going to be, first I would like to make you understand, starting from a scratch of the image processing. I would like to give you an outset like what is digital image first, because without knowing what is a digital image, we cannot think about a processing of an image. So first I would like to give you how you look into an image. Okay, that's the title slide. I have given an image with full of numbers, the eye image with full of numbers. So how do you look into a digital image? And after that, how to do a processing on an image. So these are the first two small introductions which I would like to give. Then key stages in digital image processing. I will be touch basing on all the techniques involved in digital image processing. So touch base, I will not be going in depth because it's again, I would say image processing itself is a big ocean. We cannot go on with all the techniques in one stretch in a 1 hour duration. So I will be going on with giving you an outline of all the image processing techniques. We have to be say around 10 image processing techniques over here. So I'll be giving an outline of all the techniques, 10 techniques, and 3 techniques, namely the reconstruction, segmentation, and object identification. I will be explaining this with some practical applications, and finally discuss on what other applications this image processing can be applied to. So this was going to be the outline of my session, maybe for another 30 to 40 minutes. This will be my presentation. So what is a digital image? So representation in a two-dimensional way. So any signal, maybe we say it as a one-dimensional signal. You would have seen the ECG signal, you would have seen earth seismographic signals, you would have seen various signals, or just take it to be a pure sine wave or a cos wave. Any that is called as a signal, which is going to be in terms of a one-dimensional. So the same signal, when I represent in terms of a two-dimensional quantity, namely maybe one is my x-axis and one is going to be in my y-axis, then I can say it to be as a image, provided that these two-dimensional quantity is filled off with some numerical value. So on the other hand, I would say image is just a pure matrix. Okay, so if I say my image size is going to be 256 cross 256, I mean to say it is a image of a matrix size of 256 cross 256. And now you have HD image, high definition image. Maybe what you have, what you are looking into the screen is now a high definition video. So it comes around 720 cross 1280. So it is again what we call as a resolution 720 cross 1280, which is the resolution. And again, it is nothing but 720 cross 1280 matrix. Okay, so this is a pure image. So a matrix is to be considered to be as a pure image. So how does I get an image? I get some light source. Maybe sun is the primary light source for us, or any other light source. Maybe you have a artificial tube light or something. You have a light source, light falls on an object and it gets reflected from the object. It is captured by some imaging sensors. Maybe let us look into the sensor which everyone uses now with the mobile phone camera, okay, or optical sensor. So that optical sensor captures the light which is reflected by any object. So when that camera captures an object, it becomes a image with some size, maybe 720 cross 1280, which is going to be a 720 cross 1280 matrix. Okay, so now this matrix will be containing full of values. So you imagine 720 cross 1280, this matrix to be as full of values, and these values is what we call it as your pixels, or simply some digital numbers, which is going to be called as your pixels. Okay, so what is going to be this pixel? It is the intensity of the light which is received by the sensor of your camera. Okay, this any sensor of your camera. So there are different values which these pixel values can take up. We will discuss that in later. So looking into this image, so you have any you can have image of any size. Okay, so I am giving you a normal HD image. It is a high definition image which is going to be 720 cross 1284. It can be of any image size. Okay, so all of these are going to be, all these images are going to be of having some pixel values, and this is nothing but some numbers. We'll go into that numbers next. So, but here I will given you an example. You have some, you can look into some object over here. Yeah, you look into some object over here. So as I said, it is going to be a matrix. See how this matrix now looks like. So you have a image represented over here. It's different shades of black and white you see over here. So each box or each unit of this matrix is going to be represented by a number. So you on the right you see image of a deer. So when I zoom it to that extent, and again it is going to be looking into a small unit of this image will be called as your 1 pixel. So as I keep on zooming it, I will be looking into the smallest element of any image, which will be called as a pixel, and this pixel is going to be nothing but some digital numbers. Okay, so there are different ways in which it can be represented. Okay, so yeah, so these are some image types which we can have. So okay, so if I have only one sample per point, that is a pixel will having a pixel location, maybe I can take it to be as 0, 0 at a location 0, since it is to be a two-dimensional one. They say it as 0, 0 of a matrix, or some 1, 1 of a matrix. So if that location or that point can have only one sample, then I can have it say to be as a black and white image or a grayscale image. So when do I say it as a black and white image? Okay, so if I have just two values, either a 0 or 1. So 0 denotes for black and 1 denotes for white. So if I can have only two values, maybe 0 and 1, then it is called as a black and white image. And if I have values anything between 0 to 255, then I say it to be as a grayscale image. Okay, so that is what you looked in this previous image. So this is a grayscale image. On your left you have a grayscale image. So you see shades from black to white. Okay, so 0 represents your black, 1 represents your, so or 255 represents your white. So as you move from 0, you are moving towards the white color. So maybe around 100 or 125, I will be having a grayish shade. Okay, so this is how a grayscale image is going to be represented. And we can look onto this image. Okay, so I have a scenery, just it is going to be a black and white scenery. Okay, it is a terrain, it is a hill region, okay, with waterfalls, water flowing it, but these details will not be available in case of a black and white image. And below I have given some sample values over there, so it happens to have only 0 and 1. Okay, on the other side, the same image I'm showing it to you in case of a grayscale. Now you see the values are going to be contained somewhere between 0 to 255. So 0 may represent to be as a black, or 255 to be represented as white. It can be the other way also. It depends upon what type of convention is going to be followed here. You may follow the reverse convention, where 1 may represent black and 0 may represent white. Any convention may be followed over here, but the objective here is, the idea followed over here, if it is a binary image, the pixel value will have two values, either 0 or 1. And if it is a grayscale image, it will be having values anything between 0 to 255, and that will be giving you a gray shade. So between any shade between black and white. And moving further, the next one is a color image. So you see the same image which is represented in black and white, it is represented in a grayscale, it is represented in a color. Okay, now moving into color, it has 3 samples at each point. Maybe at point 0, 0, you see you have 3 values, 255, 0 and 255. So 3 values, 3 samples and 3 values, in the sense, first value represents your R, that is your red color, second represents your green, and third represents your blue. Okay, So if you have 3 samples at any point, then that point will be giving you a color. Okay, that point will be giving you a color, and that is why we call it as a color image or a RGB image. Okay, and of course, still moving on to further, we have the 4 samples per point, which is called as your the fourth point is called as your opacity. So we will not be discussing into that extent as of our discussion is concerned. We will be discussing only in terms of uh, black and white, gray, as well as your color image. Okay, so the idea, this is the outset of how a image has to be represented, or how a digital image looks like. Okay, in case of black, what should be the values, pixel values? In case of grayscale, what should be the pixel values? And in case of a color image, what should be the pixel values? So with this idea of keeping in mind what is an image, now moving into an image processing. How do I process these images? Okay, so why do I do this processing? As I said in my introduction session, so without giving a processing, or without doing a processing, I will not be able to convey my whatever I would like to convey. I will not be able to give the idea of what I have in my mind. So I need to go for an processing. So apart from giving an idea, I can extend the processing to storage, transmission, reception, and various things. Okay, so this will be understood as I move towards the application where all my processing is going to be used. But uh, now people say that image processing is an older version, and we now move into computer vision, we move into artificial intelligence, and so on. Okay, and there is always a fight between an image processing, computer vision, and pattern recognition. There is always an argument that where does image processing stops and computer vision starts. Okay, this is always a debatable one, where image processing stops. But we would say that wherever the image processing may stop, but without image processing, we may not move into computer vision. Image processing is the fundamental for computer vision, let it be a computer vision or pattern recognition or anything. So I would say computer vision and pattern recognition are all higher ends or higher versions of image processing. And without the basics of image processing, we will never able to go into the applications of computer vision or pattern recognition or even artificial intelligence if it is going to be in terms of an image processing. Okay, so I am giving you the clear differentiation where we can stop on with image processing and where we can move on with computer vision. Sorry. So when I say it to be a low level processing, where I say my input is going to be an image, I do some processing such as noise removal. I do some sharpening techniques. Maybe I brighten up the edges of the image, or some application there is a need for even to blur the image. So I do a blurring over my image. Okay, I increase the contrast of my image. I increase the brightness of the image. That is what you do in your televisions and all those things. You just press a button to increase your brightness, and the brightness of your channel, whatever you're looking into, the content you look into, that automatically gets increased. It is purely but yeah, image processing technique. To explain it to you, I said I have explained you about this pixel values. So if I increase my pixel value something around 50 to 100, it means purely I'm increasing the brightness of the image. That's it. It is a very simple process. Okay, so it not in a single location but throughout the image. Okay, so entire portion of my image I increase by a constant value of 10 or 20, then my picture brightness gets increased. Okay, this is a very simple or a low level processing which we have in image processing, increasing the brightness, increasing the contrast, or doing some noise removal process is a low level processing. But the basic idea is the input is also going to be an image, and the output also I get it as an image, and this is a low level processing. Then I move on to the next level or a mid level, which is called as a mid-level processing, where input will be an image and the output will is going to be some attributes. Okay, so maybe I say I do a face recognition operation. Okay, so you have nowadays the mobile phones come with face recognition feature. You have a fingerprint sensor in your mobile phones. Okay, all these are some mid-level processing. Okay, after you keep your fingerprint, or after you show your face through the mobile cam, it matches with the already stored pattern or the stored image in the database. It gives you some values, maybe true or false, and based on that attribute, either your screen gets unlocked or your screen still remains in closed. Okay, so what is the output? I have not improved my feature. I have not improved the quality of any image here. It's just a matching process which is going on between the either a fingerprint reader and already existing fingerprints, or it is going to be a matching, feature matching, which is going to be done between the existing already captured face and now what is going to be shown into the camera. Okay, so will be the outcome? So it is either true or a false outcome. So that is what I called as a attributes here. Okay, so this is called as a mid-level processing. But it in order to get this attribute as an output, again the underlying base is what image processing techniques. It is not simply a one-to-one matching. Okay, it is again has a heavy computation of including the low level processing, because now you may be standing with a peculiar example which I can give over here is, maybe when you stored your face before as a database, you would have stand in front of a sun and captured an image. But now we are standing in front of a normal tube light inside your home, you are capturing in a night mode. Okay, now again there is a difference of two images. Okay, but still your camera says that yeah, it is the same person and your screen gets unlocked. How does this happen? Okay, so there is again a heavy computation which has to be done inside. If at all you have noises, that has to be removed. If at all you have blur which you are capturing now, that has to be removed, and matching has to be done. So again, it is not a very simple task like true or false, but a heavy computation lies behind that. Okay, and I would say up till this is what we have as a image processing. Moving into high level processing, that is what we say as a recent trend of computer vision, pattern recognition, all those things. These are going to be, you give your inputs itself as attributes. Okay, and output is going to be some understanding. Okay, the example which I can give over here is the driverless car which the Google is testing nowadays. Okay, so it is again it is again involves heavy image processing. Okay, you have the cameras installed in front of your car, back of your car, at your sides. Okay, so all these cameras together give your image as your inputs. They are correlated. Then other sensors which you have, the distance sensors, the IR sensors, all these things have to be correlated. These are going to be all attributes, not a single attribute. All are going to be as acting as an attributes. Now a computation has to be done so that the car doesn't hit over the front car, or it doesn't make break suddenly. All these things are to be computed, and it has to go for a navigation. So it goes on, it drives on its own. Okay, so this is what we call as your computer vision. And but it cannot, when I say it is going to be an attribute, it doesn't say it to be, it has nothing to do with image processing. But because image processing is the fundamental, where as I said, the low level processing, you start from the scratch, that is the basic removal of noise. Okay, so all these things has to be done if you need to understand your situation. So this is what I mean by a computer vision. Okay, and of course the pattern recognition. The pattern recognition is also a high level computation which is involved over here, which again requires purely image processing. Okay, so I'll move on further. So this is going to be the various stages which are involved in your image processing. As I said, if you have seen over here, you will be having approximately exactly around 10 stages which are given over here, starting from your image acquisition. Okay, so how do you acquire your image? Okay, simply you cannot acquire an image. You need to have peculiar sensors for that. We have huge variety of sensors. It is not only you may be looking into the sensors only which you have in your mobile phones, but there are huge variety of sensors. You think about the sensors which we have in our satellites. We have hyperspectral sensors, multispectral sensors, we have UV sensors, IR sensors, we have night vision sensors. So even when there is no light, we have CCTV cameras in our homes, you have in your colleges which are installed, which uses IR camera. So IR rays are going to be emitted over here. So what is the difference in all these sensors is going to be the wavelength at which the light is going to be emitted by these sensors in order to capture this image, or the wavelength at which these sensors will capture the image. Okay, this is going to be, so in our electromagnetic spectrum, that is the radiation which is emitted by the sun, so they have a wide spectrum. Okay, so the only the visible spectrum is what we see, that is the colors in your WEBNIAR, that is what we see. But apart from this visible spectrum, we have UV rays, we have IR rays, we have so on, we have gamma rays, we have X-rays, so on. So X-rays is used for we use it for medical applications. So we have the various range of wavelengths at which the electromagnetic radiations comes on earth, and whatever wavelength at which we capture, that is going to be your image acquisition. So with this is purely with respect to a hardware. It has nothing to do with the software part where we can manipulate. This is purely related to a hardware. But even in this now, image processing part is going to come in. So how do I say that? Sometimes, for example, giving you a scenario of unmanned aerial vehicle, okay, where this is used by defense people in air force and all those things. They use unmanned aerial vehicle where they monitor the border portions, they monitor the movements in sea, all those things. They cannot afford to go on with very high precision and high resolution cameras always, because there is always a chance that these can be shot up by an enemy point of view. Okay, so they don't want to invest in very high expensive cameras when we go for such type of monitoring purpose. So what is to be done there is, now we have algorithms and softwares. Even your image is going to be a very low resolution image, and you will be able to transfer it into a high resolution image. So hardware I'm not going to have very sophisticated hardware, but still I can have software which will be converting into a high resolution image. And this is one which I will be discussing with practical application. This is one reconstruction which I will be discussing in super resolution image reconstruction, which I will be discussing in one of my later sections. Next one, moving into the image enhancement. This is again comes into a very lower level category. As I said, just pure removing of a noise, removing of unwanted distortions. Okay, and then removing of some high frequency components, removing of, maybe you put a high pass filter which passes only high frequency components, then it is going to be a high pass filter, then it is going to pass only high frequency components. You are filtering out low frequency component. That is again a filtering technique. So next one is going to be a image restoration. So again here I'm going to restore, even if my image is going to be degraded, then I will be able to restore it to my original image. There may be a question at this point of time, what is the difference between an image enhancement and image restoration? If I am able to know what is the noise which have degraded my image, or what is the noise which have affected my image, then using that degradation factor, or using that degradation principle, I will do an inverse process and I will be able to restore my image. Whereas in my image enhancement, I will not be able to know the degradation factor at all. It may be some factors which have caused my image to degrade. I am not aware what is the factor, but I blindly do an enhancement. That is what I said as an example. You increase the brightness of your TV, or you increase the brightness of your monitor. You don't know for what reason you are not you are not, you're visually, you're not satisfied with the brightness, you just increase. Okay, but what is the reason for the image being dull? You are not aware. Your eyes has not pleasing sight, so you are blindly increasing the quality of an image. That is, you are increasing the brightness of an image, you are increasing the contrast of an image. That is a blind way of doing. Okay, some may feel that increasing to a factor of 10 is good, some may feel that increasing to a factor of 15 is good. So it varies from person to person. Okay, so that is a blind processing which I am doing. That is what I called it as an enhancement. But when I know what is the noise, okay, so then I say it to be as my image restoration. And next one is going to be color image processing. So as I said, black and white, grayscale, and of course color image processing is going to be a separate one. Okay, because as I have given an introduction, RGB alone is not going to be the color. Okay, we have various color models. So as you see in this slide, CMYK model. Okay, this is another color model. Okay, so you see different colors in this. RGB is given on your left and CMYK is given on your right. So which stands for cyan, magenta, black, yellow. Okay, so this is another color model. Okay, it need not be always an RGB color model. We have another model called as your HSI model, which stands for hue, saturation, and intensity. Okay, so depending upon what type of application I'm going to use, depending upon the wide range of color which is required in that type of application, I can choose different color models. Okay, so this is what we mean by a color image processing. Then moving into wavelet or multi-resolution processing. So this is of course wavelet is going to be a recent trend which researchers is going on, and or many concentrate on this, which is again a pure mathematical model, but again it is used in image processing to represent an image in various resolutions. So as you see this figure, the image of this girl is going to be decomposed into various levels. So initially it was around size of 256 cross 256, then it is reduced into half, then it is again reduced into quarter. Likewise, it keeps on reducing. But as I keep on reducing, I'm able to extract more and more details from it. That is what you see over here. Here the details which I see is different, and here the details which I see are different. And as I keep on reducing the scale on which I visualize the image, I will be getting various scales and various informations from this image. So that is what just it is going to be used to represent in various scales or in various spatial resolution. Next one is your image compression. So as you know, you when you save your image, you save either in JPEG format, you save in MPEG format, you save in bit format, you save in TIFF format, PNG format. There are various waves in which we save an image. Okay, various formats in which we save an image. Of course, each formats have their own drawbacks and advantages. Okay, probably when we save in our system, we go for the extension .jpg or jpeg, Joint Photographic Expert Group. That is the company which has introduced this format. Okay, but I would rather say TIFF. Okay, it is the best format to save any image file. Okay, that is JPEG is a lossy compression. That is, it reduces some information of your image, whereas TIFF doesn't lose any information. Okay, there is not going to be much difference in the size of an image, but still TIFF stands to be better than your JPEG. Okay, so this is another yeah, processing technique. Okay, so where this process compression is going to be used when you go for a file transfer, when you go send in your email, or when you transfer some files, or when you have a huge volume of image to be stored. This is where compression is useful to for us. Okay, so in order to reduce the bandwidth which is required, so we go for a compression, then we transfer the data. And the next one, in case of this low level of processing, is going to be morphological processing. So morphological processing, in the sense, again coming into the pure mathematics, where you find intersection, union, dilation, mutation, all these process. Okay, so here the example I have given here is the fingerprint. Okay, so you do a correlation. So simply it is not a intersection process between two fingerprints. So inside this fingerprints, features has to be extracted. Okay, so each fingerprint, as you know, each one has a own unique fingerprint. No two persons are not going to have a same fingerprint. So each one is going to have a unique fingerprint. So when I extract some features from these fingerprint, then I can go on with the correlation process. So I will be able to do on with morphological processing. So in all these cases, so far what is discussed, starting from image acquisition to morphological processing, all these, our input is going to be as image, and your output is going to be as an image. Okay, moving into the next mid level is going to be a segmentation. So as the literal meaning of segmentation, you are going to partition off some things. Okay, so you see, I hope how many of you can recognize this image. This is a scan of the human eye. Your human eye, your retina looks like this when we go for a scan. Okay, so now the veins, the all the retinal components which is present in a human eye, the arteries, the veins, everything is can be segmented like this. So any issues in our eyes, the vein damage, all these things, the glaucoma, side effects which we have because of glaucoma, that is because of excess of sugar in our body, that will again be affecting our eyes. All these things come into this again image processing techniques. We go for a scan. This is what the doctor do and analyze, and how do they get all their feedbacks in order to give a treatment. Okay, so again segmentation. So this is a one application which I am giving, but there are numerous for segmentations. Agricultural point of view, you classify vegetation area, non-vegetation area, you classify the terrain areas, okay, rainfall areas. Likewise, you have numerous applications where segmentation can be applied. Okay, and next one is a representation and description. So here I'm able to figure out some shapes. Okay, so you want to, segmentation is different, and representation and description is, I know what is my shape which is going to be segmented. I know that I don't a definite shape or a pattern which is applicable over here. I go for a representation and segmentation to get out with that. And final one is the object recognition, so which is going to be a high level of image processing over here. So you see numerous cars which are passing on the road. You see even a person walking on the road. All these are to be recognized. Okay, so maybe in a traffic, when you recognize all these things, you can avoid a collision. You can go for a number plate detection, and all these things involves image processing. So the last four which I've discussed, okay, the morphological segmentation, this representation and description, object recognition, all falls under the category of high level of image processing. Morphological alone can stand in both. It can be a low level or a high level, depending upon what type of output is required on that particular application. So these are the 10 stages in which image processing we can extend up to. Okay, beyond this, if we go, we now, there is an argument that it is going to be a computer vision or a pattern recognition, but without these steps, even computer vision or pattern recognition cannot be worked on. Okay, so out of this, I'll be going into reconstruction, that is which falls under image enhancement. Then I will be going into segmentation, okay, and I'll be going into one practical application which will be involving object recognition, and of course some basic steps. Okay, so this is the entire way stages in how we can work on with image processing. Okay, so moving into a specific topic which is called as a super resolution image reconstruction. Okay, so this is what a area which I said you have a limitation in your hardware. You have a low resolution camera, but still my image processing technique can convert it into a high resolution image, and that is what I call it to be as a super resolution. So it is nothing but converting a process of converting a low resolution image into a high resolution image, provided that that low resolution is a image, meaning that it is going to be affected by some external factors such as noise, blur. These factors may be due because of anything, maybe because of your sensor, maybe because of atmosphere, anything. Okay, there are various factors. So as you see in the image, you can have be capturing a multiple scene, that is you are capturing a video. Okay, so the scene may be moving. Okay, you may be located, your sensor may be located in a stationary location, but the image is on a moving. Then what will happen? Obviously you will have a motion blur. On the other hand, even if the scene is going to be remaining and you are in a that is the camera is going to be in motion, when you move in a train and even you try to capture a same object, even if you focus on a single object, but when you are sitting in a train and try to capture, again you will be landing up with a motion blur. Okay, so there are various factors which will be affecting the quality of the image. Okay, so all these things can even still be handled by using a software, and that is what I call it to be as a super resolution image reconstruction. So I've given you an example image over here. The first image is going to be a image captured on a still camera, but when the camera starts moving, I mean the sensor starts moving, then you face the motion blur. Okay, so there may be other factors, atmospheric blur, sensor limitations, and so on. Okay, all these are going to make my image into a low quality image or a low resolution image. Okay, resolution in the sense I'm talking about the quality of the image over here. So all these things can be tackled by my software. So I am proposing here, or I'm introducing here a technique which is called as a singular value decomposition, SVD based super resolution image reconstruction. A very simple one. Okay, I'm not sure how many of you are aware of this term singular value decomposition, but quite predominant mathematical uh, decomposition technique. So let us move into. I will not go into very depths of this mathematics, but giving you a just an idea where you can apply it on your own. Okay, in future you can apply it on your own using such techniques. Okay, so just consider I have an image A which is going to be of size m cross n. Okay, any size, let us take it to be m cross n, and when I apply singular value decomposition, that image A gets split up into three matrices now. So okay, I can say it as U, S, V, and U, S, and V. Okay, so what is U over here? U is going to be called as the left singular vector, which will be containing the eigenvectors of A transpose A. So A is our original image. So it is decomposed into three using a single value composition, and you will be having the left singular vectors, that is called as your left singular vectors, in the sense it is nothing but eigenvectors of A transpose A. And S is going to be another diagonal matrix which will be containing the eigen values. So it is, I hope you know what is a diagonal matrix, which will have only values in your diagonal elements. Okay, diagonal elements. All the other values are to be as 0. Okay, so now this will be having only values in your diagonal, and these values is nothing but eigen values. And again, V is going to be a right singular vector which will be again containing the eigen vectors. Okay, so this is the idea of singular value decomposition. It is not anything related with image processing. It is just a mathematical technique which contains eigenvalues and eigenvectors in a matrix. So any image, when I apply SVD, single value decomposition, it gets decomposed into three matrices, namely U, S, and V. U will be left singular. S will be a diagonal matrix with eigenvalues, and V will be right singular vectors containing eigenvectors. So this is the idea which I am going to apply inside my image processing. So this is the algorithm which I am going to follow. So I have an image, namely take it to be as A naught. Then I have another image, same scenery. I am taking another captured image. So why do I take two image in the sense? So some information which are not captured at my first instant may be captured in a second instant. So I am trying to bring more information into my image. So I'm taking two images of a same scenery. I go into image registration. What is image registration? There may be slight change in the angle in which you have captured, or maybe you have given a slight zoom. When the second time when you have captured, you maybe have given a slight zoom. That is called as scaling. Okay, so all these things has to be rectified. Both has to be brought into same scale. Both has to be aligned in a same way. So I'm doing on a image registration process. Then I am applying SVD, that is singular value composition on A naught as well as A. Okay, so when now I will be having totally of 6 matrices. Okay, so namely U naught, S naught, V naught, and similarly UI, SR and V. UR, SR, and VR. So I'll be having 6 matrices. Out of these 6, I'm going to concentrate only on my S, which is going to have the eigen values. So right side you see, this is your diagonal matrix. So as I said, it will be having only diagonal elements, that is your eigen values. So I make a comparison between the S naught and SR. So whichever value is maximum, I replace it as my S. Okay, and I bring it to my original U, S, and V. That is, I do the inverse decomposition. That is, I just multiply U, the new S which I have formed, by taking the maximum value and again multiply it by V. Okay, so when I bring it up again to be as one matrix now, that is called to be as my reconstructed image. Okay, so here now it will surely contain you with more information than what you have captured in a first instant or a second instant. Okay, so how do I say that? I have combined the information contained in both the images. It is as simple as that. I have taken two images, I have combined the information in both the images and again brought it into one image. Okay, but simply you cannot add. So I am going on with the mathematical notation that is called as a singular value decomposition, out of which I am taking the eigen values alone. I'm finding the maximum eigen value, and again I'm doing the inverse decomposition to bring it into an original image. So I can give you an examples out of this. Okay, so the image A which you see is the low resolution image which was captured by an camera, and the image F you see is a high resolution image which is improved by using this singular value decomposition method. In the original low resolution image, you are not able to read what was written over here, but whereas in this SVD method, you are able to read that the sentence which is written over there is colors makes the difference. Okay, so that is how this image processing technique, even without having hardware limitations, even though we have a hardware limitations over here, it is still able to give you a high quality image. Okay, and of course I have given you the other methods. All these methods, projection on convex set method, Pappler's curve method, these are other methods which are used in super resolution for image reconstruction, but we don't have time to discuss each and every method. But I have given you how the procedure for the method which gives you the maximum efficiency, that is the singular value decomposition method. And this is a real-time example. Okay, as I said, in unmanned aerial vehicle which is captured by drones, images captured by unmanned aerial vehicle which is drones. So in the low resolution image, you are not able to see the object which is present here. But in case of a singular value decomposition method, you find that there is some object, maybe a small vehicle which is present over here. On top of the roof, there is a black spot. In the low resolution image, that was not visible. But when I go for a improvement in my resolution, then I am able to identify the black spot which is available on roof of a house. Okay, so these are ways in which, even though we have sensor limitations, you cannot always depending upon the hardware to give you a high resolution image. So we are now moving into a software still to give you a high resolution image. So this is one way in which a resolution can be improved using a image reconstruction. Then I am moving into the next part, that is called as a segmentation. So again, the practical example which I can show you is spotting of disease in the leaves. Okay, so you have acres of land, and maybe a small portion of your land may be infected with some disease. Okay, some leaves alone may be infected with some disease. Okay, if it is going to be captured, you may give some fertilizers, or you may spray out some disinfectants to that region alone, instead of spreading out to the entire field. Okay, so these are some applications which are really used in foreign countries. Even maybe in India, we are not so sophisticated to capture the image of the farming land and use the fertilizers and everything to that specific requirement. But in foreign countries, still they capture even the images of the land which they have. They put manure, or they apply fertilizers, they use pesticides only to the affected region. Okay, so this is how segmentation is going to be used in agriculture field. Okay, so again here, I will not go again, as I said, I will not go into the mathematical part, just giving you how image processing is used here. I have an input image that is going to be a leaf image, or any disease affected land area. Then as I said before, you have various color models. So see, you see here now I am using a RGB color model. I am taking the red component allowed, and I have another color component called as my HSV, hue, saturation, and my intensity. So I am taking the H component of that alone, and I am having a grayscale component alone. Okay, so I am having a same image, I am taking the grayscale component of that image. Okay, so you may be having a question, so in a single image to do a processing, why should I require three color components, three color models? Why should I have RGB model also? Why should I have HSV also, grayscale? Because in this application, when I capture the image of a leaf, it may be captured in different illumination. One may capture with sunlight, one may capture without sunlight, one may capture when the sun rises in the morning, one may capture when sun sets in the evening. Okay, so your image will have different lightings, it has different illuminations. So my segmentation should not go wrong because of this lighting illumination. So in order to tackle this, when I go for different color models, all these will be tackled. And of course, another thing, when you capture, you cannot capture a leaf exactly. You have other crops which are going, you have some small grasses which are going along with your leaves. You have some soil background which is present over there. So you cannot specifically focus on to the plant alone. You may be having other backgrounds also which is coming along with your image. So this has to be removed. So in order to do all these processing, I'm going for different color models which will be helpful for me. So with these color models and applying different filtering techniques, that is pillbox filter and difference of Gaussian, I will not go into all these things in depth. I am generating a color map again, that is comprehensive color feature map. Okay, based on that feature map, I'm going to binarize my image. Binarize my image in the sense I'm going to convert it into a black and white image, with either with value 0, or 1 or 0 or 255. Okay, I'm going to convert into a black and white image. Then I go for a morphological operator which says, okay, disease is present in this area. This is a disease which is present. Okay, so this is how this processing takes place. So you see, it is not only one stage of my image processing which is applicable in this application. I need color image processing. I need filtering techniques. Filtering techniques in the sense image enhancement techniques is used to be here. I need morphological operations to be applied over here. I need several stages of image processing techniques to be applied over here for this application. So giving you the sample. Okay, so on the left, that is image A, you see different leaves which affected by disease. All the spots which is present in these leaves are affected by disease. Then I have used the red component. I have taken the RGB color model, and I have taken the red component alone, which looks like this. Then in my HSV model, hue, saturation, and intensity, I have taken the component alone. So now in different color models, this is how my same image looks like. Okay, so this is how. Then I go for a grayscale conversion. As I said, RGB, HSV, and grayscale. So the different ways in which I have obtained my grayscale image. The primary software which we code all these image processing is MATLAB. So using a MATLAB inbuilt conversion, how my grayscale looks like, using my grayscale based on SPD, how my grayscale can, of course, this will affect the efficiency of the output which we get. Okay, so that is why I'm giving a comparison. So the red lines denotes you the difference in MATLAB conversion and a normal SPD conversion. And finally, how my segmentation goes on after doing all these processing, morphological, binary. So now you see only you have either a black or a white. So I have converted into a binary. Then I do a morphological operation, and finally I segment my disease spots alone. So still processing it, still I can calculate what is the percentage of disease which is present in this leaf. Okay, I can go to that extent. So maybe I have 256 cross 256 image. So how many pixels are going to be affected by disease? So how many pixels have black spots? So then if I calculate, do all those calculations, then I can go on with even telling to what is the percentage to which it is going to be affected. Okay, so this is one application, how image processing can be segmentation, image processing stage segmentation can be applied in case of agriculture point of view. And moving into the last application, where object recognition. So this is one part where we are currently started working on. Okay, so it is even for us, it is in initial stage. We have not arrived with our results, but I just giving you an idea how we are proposing and how we are going to work on this. So you see here you have lace packets, different lace packets. That means different colors, because of that they have different flavors. Now my objective is to giving you this image without any information. I should identify this is lace chips of this much weight, this is the rate, this is the flavor, everything has to be given. Okay, but you see all the lace packets look similar. They only differ by color. You don't the text which is written on them, because of the flavor, all these things are not known to the computer. You just give this as an image, then the system, my software, has to tell that okay, this is a lace packet of tomato flavor, it is MRP is 10. All these things the system should 10. There are lace packets with 10 rupees, there are lace packets with 20 rupees, and so on. Okay, and when a customer goes to a retail shop, he may purchase so many products, not only lace chips, he may purchase so many products, he may put it into a basket, go to a billing desk. So now when you go for a grocery shop, what do? They take the product, they put it in front of a scanner, and based on the barcode, it gives you what is the product and what is the price, everything. So based on, it is purely based on a barcode, or now we have moved into QR code. Based on all these codes, it is going to be given. But what we say is, I don't have QR code, I don't have a barcode, nothing. I just have my product. When I show it in front of a camera, it has to recognize it. Okay, it is Lace chips, or it is going to be a toothpaste, or whatever it is. It has to know what is the weight of the packet. It has to then determine its cost, everything. Okay, so that is what we are trying to do now with image processing techniques, and this is really now required in a retail market. So the big merchants which are now coming into the Amazon, the Reliance, which have made a tie-up with Amazon, all they are in want of this. Okay, so that there is going to be a huge competition in this, because maybe we have we have very little time. But anyhow, let me tell you this. The Reliance market which we have in Kattur, okay, they display some products in front, they put some products at the back of their shelf. Okay, that is at the end of the shelf. But as soon as you enter into the shop, they give you a display of some few items. It is not because of the discount which they give to us, because whenever they display such products in the front, they get a huge discount from the manufacturer. Okay, so whenever a manufacturer is going to give a discount for the Reliance retailer, he should be made clear that this product remains on the front, that is in the entrance always. But what do these Reliance people do? Once they keep 10 packets, after these 10 packets gets sold, they bring some other product in the front. But what the manufacturer always wants his packet to be on the front, because he is giving a huge discount to the retailer store. Okay, so all these things has to be monitored by a image. He cannot come and make a person sit in every Reliance store throughout the country and monitor this. All these things you want to monitor automated in some software. So what will they do? They will install CCTV cameras throughout the Reliance store. This will be automatically capturing the videos through a 24/7, all the throughout the month, 30 days or 60 days. Okay, and if at all the product gets out of stock, or if the product is not put up in the rack at proper time, it should give a alarm. So that is what we are actually trying to do. Okay, so for this, first, let it be an image or a video. We can convert it whenever we have a video, we can convert it into an image, because a video is going to have 25 to 30 frames. Okay, so the 30 frames put together for a 1 second is going to be a video. So converting to video to image is not a big task. So whether it is an image or a video, it is not going to be a matter. We are going to work in image. We do some pre-processing. So as I said, pre-processing, you remove noise, you enhance the image, you remove the translation, rotation, scaling effects. All these things are done in the pre-processing stage. And now I'm moving into a object detection and recognition. So again, when I come into object recognition and detection and recognition, I'm going to categorize it into three. That is, one is for my text, one is for my shape, one is for my color. So by text, I can, if at all text is present, text may not be always present in a product. Even this same lace chips, if you put it on the other side, upside down, you will not be able to detect it as a lace. Okay, so if at all I have a text feature in my product, then I will use my text feature. If at all I have different shapes, okay, the Horlicks bottle which comes, a smaller bottle which gives you 250 gram, the same Horlicks bottle, the font is same, the text is same, but only because of size, that is 500 gram, it is going to be a bigger size. So based on a shape, based on its size, I'll go for what is the weight or what is the quantity of the product, then based on color. So last one, I keep it to be as color. So if at all I have given you the example of lace, so if at all I have to go by color, I can go on with color. So based on these three features, I can go on with my object recognition. So problems which we face are numerous problems. Okay, so when I say text, the text need not be always uniform. It differs from each product to product. and the way in which it is written. Okay, so you have curved text, non-uniform text, all these things have to be satisfied and matched when I go for a text recognition. Okay, and the shape, always the shape, you have again have a Horlicks bottle of 500 gram and a Boost bottle of 500 gram. Both are going to be of same shape, same size. Okay, so again there is going to be a contradiction over there. Then I have to go for a next feature. Then the last one is, as I said, color. I have to go on with different color models. I cannot stick on only to RGB color. I have to go on with different color models. So clubbing all these things together, then I go for my object recognition. So this is what something which we are now totally working on, and this is a total requirement of industry in today, the retail market, which they are in already a requirement of. Maybe in foreign countries, they have sophisticated such systems, but in India, we are not still to the extent that we are still using in barcodes and QR codes. Okay, so this is one practical application which I would like to discuss with you. And finally, this is all the discussions which I said. Moving on finally into various applications, medical applications. See, you see on your left the X-ray image. Okay, the X-ray image which is of a chest. The top one is going to be affected by noise, and using reconstruction method, and if I know what is the noise which has affected this image, I can bring it to the original image. Then inspection of the PCB boards, and finally for aerial imaging, all these applications. So all these are improved using a image processing technique. So you see this PCB board is just white and black noise. That is, we call it as salt and pepper noise. That is the grains which you see in your television. Okay, white and black speckles which you see in your television, that is to be removed. Okay, so now you see your PCB board to be as clear and crisp. Okay, so these are some image enhancement techniques and various applications, starting from basic medical to what all aerial imaging, everything it can be extended. And coming into industry inspection, so again PCB board is given over here. Here you have a tablet strip. Okay, whether the tablet is present inside a strip or not, because anytime the tablet, it is a thin strip, you may miss on a tablet. Okay, so instead of having a manual inspection in all these cases, you can have image processing techniques to go on with the inspection and all these things. So the bubble which you see over here, it is really a challenging task. This is simply not a bubbles, it is actually a nuclear reactor. Okay, inside a nuclear reactor, you know, it is the bombarding of atoms to produce of high energy. Okay, but because of a small bubble in the nuclear reactor, it may burst at any time. Okay, so before a nuclear reaction is going to be started, that nuclear tube or the nuclear equipment goes for an inspection. So X-ray beams are going to be passed, or gamma rays are going to be passed through this entire structure of the reactor. And if at all any bubble is present in the reactor, then it has to again go for remodification. These bubbles has to be removed, and then it has to be again inspected. So again here image processing is going to use, in order to detect all these techniques, you have segmentation techniques. So you can identify where the bubble is present, how many number of bubbles are present, all these things. In inspection of quantity of some content present inside a bottle, all these things are monitored using my industrial applications, are monitored using my image processing techniques. And of course, law enforcement, detection of number plates. This is a very simple task and already a very old technique. Okay, but still we have not implemented in the toll gates which we have now. Okay, they are doing again scanning with the RFID. Okay, but it is a very pretty old technique which is already present in various countries, but purely related is an image processing technique. So detection of number plates. So once you detect your number plate, the entire history of your car can come out. Okay, so what is the make, what is the manufacturer, who is the owner, everything can be brought out. Okay, so number plate, then finger recognition, face recognition. So you see, it is a original or a fake face, all these things. So as I discussed so far, so it is not limit, you don't have any limitations of applications in case of an image processing. And the various ways, various fields, I said I have given you application of agriculture, disease spot segmentation. So starting from application of agriculture, moving into law enforcement, industrial enhancement, satellite imagery, defense application, and all the fields we have image processing to be uh, implemented. Of course, I have preliminary explained you 10 stages. All these 10 stages are used in order to give you a satisfactory output. Okay, this is what I want to explain it to you. Hope this session was useful, and this is the end of my session. Hope the session was useful, and I'm happy to have any doubts raised by you.
Any queries? Participants or faculty members, if you have any queries, unmute your mic.
Participants,
Good evening, ma'am. Good evening, sir. The session is really very useful to us.
Yeah, good evening. Yeah.
Sir, very useful to us, sir. You have explained it clearly. But I have one doubt. If you mention the names of image processing tools, that would be easier for researchers to go with that.
Yeah, image processing tools to be very, if you are not familiar with coding part, okay, then you may go on with MATLAB, MATLAB, so Matrix Laboratory. So you may go on with MATLAB. So it has various inbuilt functions on it one. So as I said, SVD. So you just have a function called inbuilt function called as SVD that will give you an output. So likewise, you have in MATLAB, using MATLAB, you have various inbuilt functions which will be helpful. So it also has its own documentation help, where you will be able to get all these filtering, whatever you want to have as a function, you just type help and that function name help SVD, it will give you an explanation of it. Okay, and the site which will be giving you all these information is MathWorks, MATHWORKS, MathWorks. But one problem with MATLAB is it has to be purchased. Okay, so it is a high cost software. It has to be purchased. But if you are not able to go on with this high price software, the equivalent is Scilab, SCILAB. It is an open source software. You can download it free, where you just Google it, so Scilab, you can download it anywhere. But it is developing software. Okay, since as I said, it is going to be an open source software, it is still in developing stage. But as of for you being in a starting stage, you will have all your necessary, as per your requirement, you will have all the necessary functions inside the Scilab also. Okay, so using either MATLAB or Scilab, initially you can start on with your coding, and you can do all these image processing techniques in that. It is up to you. You can spend for the software, or you want to go with the free version.
Sir, participants ask some questions in chat box. Sir. Difference between segmentation and feature extraction.
Okay, so in chat box there are questions. Difference between segmentation and feature extraction. Okay, so the difference between segmentation and feature extraction is segmentation doesn't require any information. That is, for example, when I go for segmentation in case of eyes, I have showed you an image. You have veins, arteries, all the nervous system which are present in your eyes. Okay, so I classify all these things. So veins as a separate color, maybe need not be even a black and white. I can even give colors for all these things. Okay, veins in different color, arteries in different color, nervous system in different colors. So that is segmentation. And feature extraction in the sense, it is not something related to segmentation, but I extract some components out of that. So in my one of my application, I said text is one feature, shape is one feature, color is one feature. So in a lace packet, text is going to be one feature, shape is going to be one feature, color is going to be one feature. I extract text out of my lace packet. So maybe LAYS, again I have to do a segmentation process there, but I'm doing a text feature segmentation, I'm doing a shape feature segmentation. Okay, so that is the difference between. So feature is segmentation is an overall structure, but I have some features present in that object. So based on that feature, I'm doing a segmentation.
Sir, some other queries also there in the chat box. Kindly see that.
Yeah, what is the difference between image processing and image mining? Okay, so image mining is no way we can say purely related to image processing. Okay, so image mining, you keep on browsing for a cell phone in your web. You always you want to buy a cell phone, you go on with looking into different, you go on with of what you are looking into, and it gives you suggestion based on what you have searched for. That is what we mean by mining. Okay, you're digging out something. The literal meaning of mining is digging out something. So you are going on searching of something, and the on the other side the background is keeping a track of you, and they give suggestions for you. But image processing, it is not a suggestion. You know what is to be done. You are doing your enhancement process, or you are doing an segmentation process or over that. So it is purely a different, but mining is different. So image mining in the sense, you are going on search of some image. So cell phone is one example which I gave, but you are searching for an image. So that is what we go for, an image mining. Hope I have answered your question. What is meant by image acquisition? So very preliminary one. So as I said, in what way you capture an image, what based on what sensor you capture an image. It may be IR sensor, UV sensor, it may be an X-ray, it can maybe an optical sensor which you have in your cell phones. What is the type of sensor, and by using what you are capturing an image, that is called as your image acquisition. Yeah, so I hope I have answered the questions in the chat.
Sir, one more query.
Yeah.
You said in the image format that TIFF is the best.
Yeah.
But many people today, they are using other formats like JPEG or PNG like that. These formats are widely used. Can you tell why? What is the reason for it?
Yeah, see, JPEG is the format which is familiar to all of us. And JPEG is the format which comes by default. When you give a save button for an image, that is the format which Windows have assigned it to be as default. So everyone is familiar with JPEG. But when we look into the background of these compression techniques, we actually classify into lossy compression and lossless compression. So JPEG falls under the category of lossy compression. So as I said in my lecture, So lossy compression in the sense you lose some information of that image. Whereas in a lossless compression, none of the information in the image is going to be missed out over that. Okay. So the as of our image processing point of view, when we look into the concept of not losing any information, TIFF is considered to be as the best. Okay, but JPEG is considered to be as a standard one because Windows and other softwares gives them the priority, and compared to TIFF, the size of a JPEG file will be little more lesser compared to a TIFF. So more compression is going to be done over there. Size is going to get reduced till that. But since the small variation in that size, but we are losing lot of information over there. So that point of view, if you don't want to lose any information, you can go for TIFF. But you say, no, I am not interested on my information. I am worried about the space. I need my file size to be reduced to 10 KB or 15 KB. I should not exceed beyond that. Then you go for JPEG, or still a lesser version of that. You have PNG, bit format. Still, you can go for those formats.
Sir, only one more query in the chat box, and because we are not having any time, please brief that answer. Brief that.
Can you explain segmentation techniques in
Can
image?
you give a brief answer, sir, because we are running out of time.
Yeah, so segmentation, I have discussed one techniques, the comprehensive color feature. Okay, that is one segmentation technique. Again, you have segmentation techniques using SPD. That is, you have to go through a lot of literatures. All the segmentation techniques which cannot be explained is in this 1 hour duration. But on my part, I have given you one technique, CCF, comprehensive color feature detection. That is again a segmentation technique. The end result is a segmentation. Okay, so that is one segmentation technique.
Sir, can you give your contact mail so that research people who are working in image processing, they can get some?
Yeah, sure. They can go on with my same ID which I have given past. That is Joseph Abraham Sundar at it.sastra.edu.
Can you type in the chat box, please? So that other participants, they can, if they are having any queries, they can contact you personally so that they can get more information.
Yeah, sure. I have given my email ID. They can contact me in this email ID. I'll be able to answer them.
Please take note of that, and you can contact him to clarify your queries in image processing research areas.
Thank you for your wonderful section, sir. We learned a lot. I now request Dr. Ranjit Kumar, Assistant Professor, Department of BCA, to present vote of thanks.
I thank God Almighty for providing us this wonderful day. I extend my gratitude to our beloved principal, Dr. D. Paul Dayabrad sir, and management for providing us the good infrastructure. And I thank Mr. Paul Davidson sir for starting the meeting with the prayer. And I'm grateful to Dr. James Manogaran, HOD, BCA department, for motivating us to organize webinar and other activities. I am an immense pleasure to thank the resource person and my beloved friend, Dr.K.Joseph Abraham, Assistant Professor, the Department of Information Technology, School of Computing, SASTRA University, for spending his valuable time and giving us valuable inputs. And regarding his session, he had given the basics of digital image processing, and he had focused more on the super resolution image processing technique, especially the SPD technique. He had given an example how this SPD technique is enhancing the image, and it is giving us a favorable output. And also he has discussed various applications of this image processing, like disease prediction in the leaves using segmentation techniques. And he had given another application like detection of product and retail stock in the market using digital image processing technique. And I given another application regarding this image enhancement in the medical field. And also he had given one more applications like industrial inspection and also how the image processing techniques is used in the law enforcement agencies. So this is what is there is presentation. I hope it will be useful to the faculties and the research scholars who are working in the image processing domain. And I am thankful to all the participants as well. And I would like to thank Mrs. Iris Punita ma'am, Association in charge, BCA department, and other student in charges for their tireless effort to make this webinar successful. And I thank the IT support for their valuable technical assistance. And once again, I thank you all for your participation. Thank you very much. Sir, can you tell your feedback?
Yes, Sanjit sir, pardon?
Can you, if you want to tell anything, please tell.
Yeah. Thank you for giving me this opportunity to share my ideas and thoughts and giving your students insight about image processing. Thank you to your management and head of the department also. And I hope the students make use of this opportunity and they will be able to do it better. And they are free to contact me. I have given my mail ID. So they are also free to contact me. I will be able to assist them in this field of image processing. Thank you, sir. Thank you.
Sir, and I request you to give you a feedback from your side.
Yeah, sure.
And we'll discuss later, and you can give it through your mail ID, sir.
Yeah, sure, sir.
So thank you, sir. Thank you.
Thank you, sir.